Speaking of reliability, a podcast with good friends talking with you about reliability engineering topics. Welcome to Speaking of Reliability. This is Fred Schenkelberg.
This is Dianna Dini.
Hey, Dianna. You know, when we were talking in the last episode, one of the things that came to mind is that there's a whole lot of stuff that's very similar for reliability.
Between reliability and quality?
Yeah. There's a whole pile of stuff that's we're one of the Italities. And, there's all these different, in some organizations, they're whole groups or departments or teams, and they're basically functions that it's like doing the data analysis and dealing with failure analysis and dealing with customer support. And some organizations look at it as a filter to protect the design teams and the manufacturing teams. Other organizations look at it as these roles are specialists that bring in a different perspective to the rest of the organization and get plugged in all kinds of places. And there's every variant you can think of. So I think what we talked about in the last episode of, what's it like working in quality and the different roles and how it performs, we could have just substituted reliability in there because there's data analysis, there's working with teams, there's working cross-functionally. It's all over the map. I think very, very similar. So here's the philosophical question. Is reliability a subset of quality, or is quality the starting point for reliability then happens?
Oh, I think they are on equal footing.
You're so diplomatic.
I don't think one is a subset of the other. They're sort of companions. I do think reliability is more specialized and technical in what it can produce and its outputs. And I think of quality as broader, covering a broader scope of issues.
Well, it could. And I agree. I'm trying to think, it wasn't Deming. There was somebody had like the 14 aspects of quality. And I wish I remember where I saw that, but it was, it's form, fit, and function. Does it do what it's supposed to do? Do you do it consistently? The user interface elements and human interaction, the minimizing human errors in the use of the product. I mean, it spans a pretty broad range of setting expectations for what's the quality of this product. It could be included into that. But there's nothing in the quality body of knowledge that says you can't do a Weibull plot.
Yeah, right.
They don't expect it or teach it in the body of knowledge, which is kind of sad, but it's okay.
Yeah, there's I've heard somebody explain reliability as quality over time.
It might have been me.
Oh, yeah.
Yeah, we do everything quality does, but we just have to do it for the duration of the product.
Yeah. Yeah. And I think of quality also involved in a lot of the user interface processes or like the voice of the customer kind of thing. Mm-hmm. Whereas when you get to reliability engineering, it's not so much as at a high level. You need requirements. You need technical requirements in order to develop and test a product for reliability.
Oh, now you're getting dangerously close to something here. We just agreed that they were very similar, right? For quality, you need you've run into it where the quality team goes through the specifications, says, all right, it needs to be at 12 PSI. So we're going to measure 12 PSI at the end of the day. And if it's not that, then it fails. We can't ship it. In reliability, it needs to last for 5 years, and then we'll go figure that out and sort it out. But as you know, that's not the whole role, is to go nitpick on the specification sheet.
No.
Right. So look at a button, right? Just say a game controller or a TV remote that has a button on it. The actual technology, there's probably a dozen different ways to create that feature on a product, to make a electrical contact. A common one is a dome, a little dome of metal that when you depress it, it deflects, it makes contact, but it's kind of like a little spring. And so when you release the pressure on it, the dome pops back up. It stands proud on your remote control or game controller, and it opens the circuit. And from a quality point of view, I would suggest that people would look at, well, how hard is it to press, right? Can the people that are exposed to use this thing actually press the button, and is it comfortable? Is it the type of button that's right for that application? Would that be a quality aspect that the team could bring into the design team to select and size the right feature, the button?
Yes.
Okay. Now, if the customer gets it and goes, this button doesn't work for me, and they return it, that very much could be a warranty claim, right? Or a customer complaint.
Yes, definitely a complaint.
Right. But warranty and returns and complaints all get charged to the warranty budget.
Yeah.
Right. Now, I think both quality and reliability, in part, not exclusively, but try to minimize that part of it. And so sometimes that button will fail just because the design is wrong. And from my point of view, that's still a field failure. Right?
Yes.
That's and so I look at the page a little askew and I call that a reliability problem, and we'll go solve it. Now, if there's a quality team, then it's, hey, can you take this on? But on the other side of it, if that button creates a crack over 5,000 activations and then fails, is that a quality problem or is that a reliability problem?
I would still say it's a quality problem that needs to be investigated.
Oh, we need to
from
talk.
A reliability standpoint.
No, and I've seen that and you've seen it, where if it comes in, if it's a failure in the first 30 days, it goes to the quality department. It's a quality issue. It's a manufacturing issue. You got to solve it over there. And if it's after that point, then it goes to the reliability team, the continuous improvement or whatever, some other team. And I think you're missing the point here, guys. A failure is a failure. The customer doesn't care what department you've got solving this thing.
Yeah, right.
And I've seen it, and I'm sure you have, is it goes to the manufacturing team and they say, well, there's nothing wrong with it. It works. It meets spec. It's fine. And they kick it over to reliability guys and it works. There's nothing failed.
Well, there's still a problem.
There's still a problem, right?
Yeah. And it's still a problem that from the customer that needs to be addressed. It wasn't supposed to crack.
Right.
So
it
you
wasn't
mean
supposed to be too hard to push or either or. Yeah.
Yeah. So you mean that just by nature of internal workings of organizations, that the way these things get parsed out, they're kind of end up in a black hole because no one wants to take responsibility?
Yeah. Or, well, I've seen it where an organization will have, and I haven't kept track over the years, all these different teams I worked with, but it was like on the order of 25% of the field problems and complaints and call center issues were no trouble found. It was, the product comes back, a technician grabs it and says, hey, it powers up. I run a self-test on it and it does everything it's supposed to do. We could sell this if it didn't have all these fingerprints on it. No trouble found or no fault found. And often those are the highest count on the Pareto of field issues.
Unknown call or not, they don't know what's wrong with it.
Right. Or they look at it and go, it works. I don't know what the customer's complaining about. The monitor won't light up, and they get the computer back and the monitor lights right up. And I'm like, okay. And I know I've talked to Kirk about it a couple of times. Says, well, let's put it under a little bit of stress. Let's do a halt test on it. And then you find the intermittent failures. You find when it gets a little bit colder, it doesn't work. Or if you're at 100 volts versus 110 or 120, then it doesn't work. Or, small variations in the customer's environment may well cause a problem. Or it's a customer expectation thing. But either one of those, and it's what you're agreeing with or suggesting, is that that's still a problem.
Yeah, it would still be a problem. And it sounds like it's root cause analysis. So if you run it through the standard quality check, is it meet the specifications, right? That compliance to a standard.
Right.
So it's turning on. I don't see anything wrong with it except for a few fingerprints. Instead of just wrapping it up and saying, well, we don't know, you need to take the root cause a little bit further. And like you mentioned, you can use reliability methods to do that, to assess the environment that it was used in, to perform a reliability test on it, see if you can find the weak component or a loose wire or something. So with complaints coming back, it's that, I guess, the quality compliance to a standard is the easiest thing to check first sometimes.
Yeah.
And then you may need to do some of those reliability tests to really get to what's wrong.
Well, there's also a part that starts right with the return authorization or the call center and so on. Those processes need to be designed well enough that you get meaningful information back.
Yeah.
It doesn't do a design engineer any good whatsoever to be told, well, we're getting a lot of complaints that it doesn't work.
Yeah. So, that's not answering what's wrong with what.
That's right. It's what do I do with that? I had one engineer, he had a big sign in his office that said, work harder. And I'm like, what's that mean? He goes, and he told a story like that. This is the customer service team did a briefing and said that 80% of their complaints are the product doesn't work. And you're like, okay, how? Does it not work? What do you mean? And I had one team that they didn't even get the products back. They were the little point of sale devices that you'd see on the cash register lanes at places, and so you'd swipe your credit card in it. So it had a bunch of security systems in it, such that if you opened it or tampered with it or probed it, this large capacitor would fry all the memory and chips. It just burn it out. It was a security thing. So that even if it did fail, you couldn't take it apart safely because it was a fail-safe security system, so that if anybody, even the technicians, there wasn't a back door or a secret way to get into it. And it was inexpensive enough that if it failed, they just threw it away. So this poor team had nothing other than, hey, it failed.
Wow.
And
so what did they do then? Were they able to start collecting some information about it's how long it was in use?
Well, that was part of it, is like what kind of environment it is. It indoor, outdoor? How often is it used? Even that was touching on the security systems. But what they did is they went to, well, how many receipts went through register 6, kind of thing, and just get a general count. They ended up doing more of a very robust beta program. So they created systems that didn't have the security features on it, and all other elements of it were pretty standard. And what they found was the card reader, it had a tolerance in it that after so many cards, and cards themselves are different widths and have different abrasive neat features and stuff like that, was wearing out that reader pretty quick, and that tolerance that was required. And so then it became an issue with couldn't read it. And then it would get duct taped and it would get all kinds of weird things done. And they had no idea until they went out and found some trusted partners that had, other ways to invoke the security system. But they went in with very limited time frames and all these other measures, but they had to really work hard to figure out a way to get information. And they never, the vast majority of their products, they got nothing back. It didn't work. Replace it. But yeah, they were one of the exceptions of all the teams I saw. But and then they ended up doing a lot more halt testing and thinking, like, did a really thorough FMEA, and then that narrowed it down for them to where to look. But yeah, they were. They called me in and they said, "We've been told to make it better." I says, "Well, what's wrong with it? We don't know." And they were serious.
That's an interesting use case.
Yeah, that was the most fascinating one. Like, all right, let's figure out what we can do here. But part of it, I mean, this idea of reliability and quality in the different ways we work with folks and the different ways we do it, I think one of the biggest things that we bring is, besides the tools we bring into it, is we just bring a different perspective. Is how do we make this consistent? How do we make this so that it works for the customer? How do we make this so it works over time? Reliability folks often think about failures and failure mechanisms always. We see a design and go, oh, it'll break this way, this way, this way, this way, this way. You know, like, so nobody wants us to come to the party.
Yeah, I've talked to reliability engineers, and it could just be the case that we get together and we lament about our common problems, but it almost always comes up, man, I wish they had involved me earlier.
Yes.
I could have helped them with that, or helped them design a test to solve that problem, or help them do an analysis to figure it out before they went through all that pain.
Yeah. Or if we looked at the data from our last 3 products, we know that vendor is sending us this crap, but you keep picking that vendor. What's wrong with you people? That usually doesn't go very far, but if you got the data, let's just use the data and inform people. But if they don't want to hear it or see it, then there's other issues.
Yeah.
Sometimes I think what brings our two worlds in common and where we can help the most is that we often ask those questions and then back it up with data or research or experiments or testing that says, what if we looked at it this way? Or what happens when? Or how does this evolve? Or what's likely to fail? Or what's likely to be in control or not in control? And it's pulling all of those various tools together. But that question of if only we were involved earlier, that's the trick. That's where we both want to be. And because it can make a huge impact.
Yeah. Yeah. The earlier you can help, design team or a process development team, the earlier you can be in there, the more positive impact that you can have. Although the teams, like you said, some of us are focused on failures, what could fail.
Mm-hmm.
So, and sometimes people don't want us around at first.
Yeah, definitely not.
But it's not that we're picking on anybody. It's just a different way to look. And I think it's a valuable piece of any development project.
Yeah. Well, I remember I saw one team and I asked, they had a prototype on a bench, and I says, "Oh, can I pick it up?" "Oh, yeah, sure." And I picked it up and put it right back down. It was hot, and it was a handheld device, and it was hot. Like, is it supposed to be that hot? And they all kind of looked at me, and one of them went over and touched it and goes, "Oh yeah, that's really hot. That shouldn't be that hot." This is, how long you been working on this? Probably not the right question. But anytime they had plugged it into charge, they just put it on the bench, and then they were doing other measurements. They were looking at power draw, doing all the other stuff. They never even thought about that the surface could get pretty hot. But, or even it wasn't a spec, wasn't anything they were going to measure. Eventually, I'm sure somebody would have picked it up. But I was like, you never noticed that before?
And, sometimes it's our training, the way we're trained to think, or that we've trained ourselves to think about problems and the customers. But also it's just independent. We're not the ones that are always running all the bench tests and everything. So just a fresh set of eyes is also helpful too.
Yeah. Yeah. And I'm thinking of like 2 or 3 more episodes here as well. One, how do you get to be on a team earlier rather than always a bit day late and dollar short? But also, there's also a part of, well, how do you actually add value early on? I mean, it's a different thing than saying, oh, we need to run this massive DOE and make sure the processes are under control and make sure we qualify all the vendors. Well, we haven't figured out what we're designing yet.
Yeah. Yeah. And but we can still provide value, even if it's at that concept phase.
Oh, yeah.
Where they don't know what they're designing yet.
Yeah.
And in fact, I think that's the perfect time.
Yeah, same. And I think that's a subject for a whole nother episode. I think that we can definitely dive into that. But anyway, I suggested this topic because I got a webinar coming up that I wanted to explore the overlap, the differences, and so on. And I think we came to, as some people would say, is an agreement. Yeah, they're very similar in so many different ways. If you're listening to this and you're working the quality group, or you work in the reliability group, or you work in both realms, or however it's organized, I'm sure some of what we talked about probably resonated with you. What are some of your solutions to get you up into the early parts of a design team or a development team, or in preventing problems versus working to avoid or recover from problems and being reactive to it? That's the question I really like to explore, and I think it can help many of our listeners that are struggling to move out of reactive only, whichever role they're in. So it'd be a great topic for a future episode. So let us know. Head over to accendoreliability.com/go/SOR, and you can find a widget to leave us a voice message, literally join the conversation, or you can leave us a written comment. Dianna and I and the other hosts of the show are active on LinkedIn, so you can find us there, and you can find us on our About pages at Accendo. There's plenty of ways for you to join the conversation, and we are looking forward to your input. So with that, Dianna, I think I still think reliability does all of quality. Reliability is just as broad, but that's just me. Quality was first. They've been around longer.
Yeah.
So we'll have to agree that we both, have cool jobs and get to do cool stuff.
Yeah, that we can agree on.
Definitely. All right. Well, thanks so much, Dianna. It helped me think this through a little bit. And we'll see what questions or comments or discussion we get from our audience. No pressure on you folks listening, but, run to your nearest keyboard and send us a note. And we'll talk to you again soon, real soon, Dianna.
No, thanks. Thanks for having me.
Cheers.
Bye.
Thanks for listening to Speaking of Reliability. We invite you to join the conversation. If you have a question or a topic that you think we should discuss in a future show, please let us know. You can find a comment box below the episode show notes, or just leave a note as part of a review on iTunes.